Okay, so we're live. Hey.
Hello.
All right, so with lesson four, part one was pretty simple, simple, I think. It was just all definitions.
Mm-hmm.
Any of the definitions, anybody have problems with them?
Um,
Or not
no.
understand them or did not make sense?
Well, I didn't think that they gave a really good definition of discrete random variable in the study guide or the book
Yeah.
online text, because then it tells us discrete is too complex for this course. So I don't know if I really have a good understanding of it yet,
Yeah.
but
Well, we know what a random variable is.
Yeah.
My,
yeah.
well, the definition on the answer key, it said it varies following a specified pattern or distribution in the long run. So you can't predict it, but it follows it over time. You can see the pattern develop. This happens more frequently than that does,
Okay.
which is why you can list it as which is why you can actually map it, is because it does have a pattern. It's just not a predictable pattern
Okay.
necessarily. You don't know what's going to come next. So,
Which is the random part.
which is the random part, and the discrete part means that you can
We
list
can't
it.
list everything.
Yeah, you
Okay.
can't list all of it, but you can list what you know.
Okay.
That you know, like, okay, like with the flip of a coin, you know it's only got these two options. It's going to be one of these. You just don't know
What
how
are
often.
heads or tails?
Yeah.
Okay.
So, all right. And so then the questions 5 and 6 from the answer guide, which is 221B, it's an
Mm-hmm.
eight-sided die that has 8 possible outcomes for each roll, 1 through 8. And it says calculate the probability of rolling greater than a 5.
So, and I didn't do that at all. I just did the 5 and 6 that's on ours.
You did the A?
I did what
Okay.
printed out from the homework assignment.
Okay. Well, I didn't do as 221A. I did as 221B. I went ahead and
Okay.
copied the question and answered it without trying not. And I didn't look at the answers; they were there, but I'm like covering it up with my hand and writing down the questions so I could try and figure it out without just having it in my head.
Okay.
Um, so we can do. Do you want to do it the way with the 4, or do you want to do it with the 8?
Well, we can do it with the 4. I'm trying to pull it up here.
The thing is, we don't have answers to check it to know that it's correct.
Yeah, I was just thinking, oh, if we all have the same answer, then we're good.
Yeah, well, because I realized it was the wrong one, I went and copied the answer or the question down and did the one that I thought it was supposed to be.
Oh,
But I don't care either way. I didn't do them the way they were written because I saw that it was from a different assignment.
oh, okay.
But it's easy to do.
Okay, I'm trying to pull it up here. It's taking me a minute. Okay. Answer key.
Yeah, because the answer key goes with B.
Okay, so then it would be 1/8 each time, right?
Mm-hmm.
Would
Yep, 1/8 possibility for each one. So to be greater than 5, it's just 6, 7, and 8. So it's 3/8
okay.
or
So then you
0.375.
would 0.375. So then you would do 1 times
Well,
0.375, then 2 times 0.375.
well, this is just the question is
Oh,
just
we
the
just want to know
probability.
5.
Yeah, this is just the probability of being greater than 5. The probability of being greater than 5 was 0.375.
Okay, so then not rolling would be 5/8.
Yep.
Okay.
So, like I
All right.
said, it was pretty simple.
Okay. So I was
So,
doing the discrete random variable and the standard deviation of the.
yes, which we can do if you want to work those, because we do need to know how to do those. We might have to do those on the test. Do you want to go to the exam or
Okay.
do the?
So this was on the preparation assignment, the
Yes.
lesson 4 preparation assignment. Okay.
Are you with us, Stephanie?
I'm trying.
Okay.
Okay, I see what you're saying. Because greater than 5 is 6, 7, 8. So that's why it's 5/8.
Yeah. Well, it's 3/8 for to be greater than 5, and 5/8 to be.
There's 3 possibilities, 6, 7, and 8, to be greater than 5. So that's why it's, because I was like, that's not right because it's 1.125, but I was doing 1/8. So 3/8, yes.
Mm-hmm.
So 0.375, and so you times 1, where'd it go? Hold on, sorry. So you do 1 times 0.375, is it 0.375, is that right? And then 2 times 3.75, like just go down, and then you add it all up.
And you add them all up, and that would give you
the discrete random variable, or the mean of the discrete random variable. That's what that's going to give you, because that's what I was trying to do. But then she pointed out that's not what it's asking us.
So that would, you do that, and then to have the standard deviation, you just square root it, right? Or am I thinking the wrong thing? Thinking the wrong page.
The standard deviation. So then you would take your, what is it? Your mean that you got from adding that up, the mean of the discrete random variable. So you would do 1 minus, because the discrete random variable is 2.5 squared times 0.25.
Oh, that's right.
And then at the end, you square root it.
And that's for the discrete random variable, right?
Yeah.
What you guys solving for? The discrete random variable, and that's it, or the mean?
What?
What are you guys solving for again? Which part?
We're basically taking, we did the B, what the answers were, we found the probability of rolling greater, and then we're taking that and using the original question and doing the discrete random variable, just to practice doing the discrete random variable.
The original question. I'm like, I'm not seeing that one on here, guys. Okay.
No, we're basically going back to the original question the way it was, but using the information from the questions we were supposed to have, so that way we're practicing getting the discrete random variable, because we kind of need to know how to do that.
We do, okay.
So I'm just making some notes here. So I'm getting a phone call from an 800 number. They can leave me a message.
That's okay. I'm getting texts from my daughter that they have the institute sending her information on what class she has for seminary, seminary, and then the school has her down for a different one, and so she's like, why won't you help me? And I'm like, need to wait a minute.
I'm busy. Leave me alone.
I'm at school too, okay?
I know, my kids, I had to remind them. I said, you do realize I'm going to school too, right?
Yeah.
Like, I'm going full-time just like you, and you still expect me to do everything for you?
Yeah. I'm about ready to make a whole new chart for them, a whole new job responsibilities.
Yes.
You have them do more. And I'm like, I know, but that takes me taking the time to figure it out, other than just giving them things to do all the time. But
exactly. Well, we have chore charts up, but nobody pays attention to them anymore. They just pretty much take up space on the fridge.
Yeah, pretty much what fire's the biggest right now, and do the laundry or whatever.
Yep, my laundry's caught up. That's the only thing that's caught up, and that's because I shuttled everything through yesterday.
That's awesome. Today's my shovel day.
Well,
after this.
Grace, I shuttled through all of ours and the kids. My youngest two. My teenagers, I don't know where their stuff is. They're on their own.
They can be responsible for themselves.
They know how to run a washing machine.
Mm-hmm.
If they're out of underwear, that's their own problem.
Okay, so are you guys working on the part 2, question 5 on the preparation assignment? Or okay.
because I didn't do that part of it, so now I have to do all the work on it.
Yeah, it takes some time.
Yeah, I'm on 8 now, so then I can add everything together.
Oh, well, it's only a 4-sided die.
Oh, we're only doing the 4-sided die?
Yeah, the question is a 4-sided die has 4 possible outcomes. So
Darn,
you only
I
have
was doing the 8-sided die.
extra work.
Well, then I did extra.
So how are you
1,
doing?
2, 3, 4. What's the
Patty?
question?
So how are
Okay,
you?
so
So the 4-sided die. Are you doing number 6 or number 5 on part 2 of part A?
Part A, we're doing number 5. So it's a 4-sided die with 4 possible outcomes. So 1, 2, 3, or 4.
Okay.
So it'll be.
So you do 1 times
They're all 1/4. So they'd be 0.25.
so that's your X value or your probability.
Mm-hmm. So it'd be 1 times 0.25 plus 2 times 0.25 plus 3 times 0.25. I can write
4
plus
times
4
0.25.
times 0.25,
Okay.
which will give me totally different numbers than what I've just been messing with because I was doing it off of the other one. La, la, la. Okay. Well, whoever called me from the 800 number left me a message, so apparently they want to talk to me.
Oh.
I don't want to talk to them.
It might be good. You may have won money.
Act now.
Once you add those all together, it equals 2.5, right? And then it says
Right.
calculate the mean of this discrete random variable. And how do you calculate the mean? Again?
Well, the mean is 2.5.
Yeah, so the mean.
So then on number 6.
The mean is 2.5?
That's what the formula is. It's the 1 times the px plus 2 times the px times plus 3 times the px, and the px on this one is 0.25.
And
The
then you add them all
probability
together.
of it being each of those numbers, the probability is 1/4,
Okay.
and that's what the px is the probability.
Okay.
You follow?
Yeah, but the mean, I guess I'm getting mixed up from last week's when the mean and the median and all that. Am I not even on the right page here?
No, you're doing right. It's the discrete random variable, and that's why it's a different formula.
Okay.
It's the mean of a discrete random variable. So that with a discrete random variable, this is how you solve for that is you use the one, it's each x times.
Times 0.25, which is the probability of getting.
So then you add all of those together, and that'll give you the mean.
Okay, so 2.50 is the discrete random variable.
Yes.
Mean of the discrete.
The mean of the discrete random variable, yes. So then using that, we go find the standard deviation, which is just the square root of it, right?
You're trying to figure out the standard deviation, you said?
Remember
No, I keep doing that wrong. You plug it into. All right, Carolyn.
So the formula would be the number, right? So the 1 times your mean, which is 2.5, and you would square it.
So it's just 2.5 square.
So for the first one, and then you would multiply it by your mean again, which is 0.25. That's.
You mean the probability?
How's it 0.03?
You mean the probability?
Yeah, the probability.
Okay, so that times.
So, Carolyn, what did you get for the standard deviation of this discrete random variable, number 6?
So, well, I got 1.180.
That's not what I got.
So, aren't you doing the square root of 2.50, right?
No, because then you've got to, after you figure out for the, I don't know what the end value is called, for all 4 numbers, you add them up and then you do the square root.
Yeah, so if you add up all those numbers, I got 2.5.
Oh, well, my first one for number 1 was 0.5625, and then I got 0.0625, then 0.0625, and then 0.5625. that not right?
Well,
Hold
if
on.
you do 1 times 0.25, that's 0.25. 2 times 0.25 is 0.50. When you times 1 times each of those numbers, what number are you getting and how did you get that?
Okay, so I did 1
Oh,
minus,
okay, wait. Sorry. Go ahead.
1 minus 2.5.
That's where I screwed up.
And then
Okay.
do the square, or not the square root, square it.
You did 1 minus 2.5?
It's the formula. It's
minus
the
1,
x,
right?
your variable. It's your x minus your population, that quantity squared times the probability. So
Let me see if I can find where the formula is. And
I'm trying to find it right now.
try to find a legible note I can show you.
in 3.1.
Finding the mean of a discrete random variable.
So 3.2.1.
So I got to pull that up on my here. Oh, come on, open already. Okay. Yes, 3.2.1 with the rolling of the die. You there, Stephanie?
Yeah.
Okay. If you look, it's got column 1 is the value, that's the x. Column 2 is the probability, which is where we're coming up with that 0.25. The value at times the proportion. Right here is the you add all those together, and that gives you the population, or the mean of the population for that x.
Which on this column 3 is 3.5030, right?
Yeah, well, it's 3.5. Yeah, for this one, for ours, it's
2.5.
2.5. Yeah. So then we come over here to that last column, and it's the variable minus the population, which in ours is 2.5, quantity squared times the probability. So then you do that for all of them, for all your all your variables. Then you add those together, and that gives you your variance. And then you square root the variance, and that gives you your standard deviation.
Okay.
Does that make sense?
Yeah, I just have to practice doing it.
Same here. I get it once we get going, but I look at it, I'm like, wait, what? Wait, what? And then Carolyn keeps me in line, and she says, no, it goes like this. And I say, oh, yeah.
Well, see, and I have it all written down, and then I couldn't remember what the formula was and where I found it.
Yeah.
There you go.
So on our, since that's a 4-sided die, so it would be like 1 minus 2.50 squared, right?
The quantity squared times 0.25.
Okay, and then 2 minus 0.25 quantity squared times 0.25. And then you just do that for through the 4, right?
Yeah, we're just doing the 4, so.
You guys, we can move to the next thing if you need to while I do this.
That's okay.
Well, the next thing is to do the assignment.
Okay.
Right?
Yeah, that's.
Yeah. So we want to make sure you got it before we.
Yeah, because that's the next. That's the next crazy.
Okay.
And I'm still doing it too because I didn't do it right.
So when you do the when you get the answers, what place value do you stop at? Do you like 1 minus 5 squared? I got 0.6495, like a whole bunch of numbers. Do you guys? When does it tell us to? Does it matter, or you just then times that long number 0.25?
I thought it said 3 place values out somewhere in the last thing.
Typically, it's looking for 3 place values. Sometimes it'll take 4.
Okay.
Yeah, 3 is usually pretty safe. So the variance, did you get the variance yet, Steph?
Not yet.
Okay.
Wait, variance, which one's that?
That's what you get when you add up all those, the
No, I keep pushing the wrong button on my calculator, so I keep having to.
I did that the other day. It was miserable.
Seriously, come on.
And so you got, and then Stephanie or Carolyn, you got for the variance you got 1.25 and the standard deviation at 1.118.
Yes.
Okay, cool. We got the same answer.
Yay!
Finally, we did the same work and got the same answer.
Well, I was checking my work,
Good.
and I was pushing. I had stuff saved in the calculator or something, kept giving me wrong stuff, and I'm like, oh, maybe I told them how to do it wrong.
I've done that. Trust me. I have. Yes, yes. I'm gonna open up the assignment so I can look at it.
Okay.
Go ahead and. It's got 13 questions. So.
Oh, the quiz.
The quiz thing, or the group meeting quiz.
Okay.
Because I'm just stressed that I'm not gonna have time. I'd rather work ahead a little.
Okay.
The first couple questions are simple. This one has it's using up to 4 decimal points on the quiz.
What did you guys get for your answer again?
For the standard deviation?
Yeah, of the discrete random variable, right?
Yeah, the standard deviation, the discrete random variable, we got 1.118.
Dang it, that's not what I got.
Did you get 1.25?
No, I got 1.391.
1.391? Huh.
Okay, just to clarify, I did 1 minus 0.25 and square root that times 0.25.
Nope. 1 minus 2.5, that squared, not square rooted. Squared times 0.25.
Weird.
And then 2 minus 2.5, that squared times 0.25.
Okay, I got it. Okay, so 1 minus 2.5, and that is squared. Okay.
Mm-hmm.
And then times that times 0.25, right?
Uh-huh. And then do that for each of the variables, for all 4 of them.
2.5 squared. Okay.
And I think they were saying the reason we do a square is so we can get rid of the negative.
Yeah.
Oh, I remember that from math before. Yeah, you're right. Okay, I'll do up the math later. And you guys got what answer again?
For the variance, when you first add all those together, the variance is 1.25, and then when you square root that for the standard deviation, you get 1.118.
Okay, I'm going to do it on my own, and I'll see if I get that answer, and then when we come back later,
we can go over whatever.
Yeah, because I don't want to keep you guys. We can move to the next thing.
Always, we're good. All right. So the first 2 questions are pretty easy. Yes, I participated. Yes, I did my work ahead of time. Okay. Blood types and portions in the table above define a probability distribution.
So I think that's asking about the rules, right? Pertaining to the rules.
I think so, and it looks to me like it does.
Follow the rules.
Yeah.
None of them are negative. They're all between 0 and 1. They add up to 1.
Provided you hit the decimal in the right place, they do. I just tried to add it up, and I'm like, wait a second.
Do you agree, Stephanie?
You agree, Steph?
Yeah. I'm actually, it's gone on my computer, so I'm having to reload it up, but hold on.
Aww.
Okay.
No, right?
Yeah, so yeah, to me, I say true.
Yeah.
What is the probability that a random selected person in the United States has a blood type O? Is that 0.45?
That's what I say. But is that a trick question?
Well, there's no other numbers to mess with.
So
to me, it's like, it's got to be, because there's no other choice.
yeah. Okay.
All right.
Okay.
To not have it is 0.55, right?
Right, because you would subtract the 0.45 from the whole.
Or you can add the other 3, but that's easier.
Yeah.
Usually they tell us to add everything, and I'm like, why? Can't we just subtract the one we know?
Why do we have to make it difficult?
Let's make it smarter, not harder. Okay.
Okay.
Are you there, Stephanie? Okay.
I'm here. I accidentally opened the homework assignment, and it won't let you save for later, so I guess I have to leave this open and figure out that too.
Oh, the homework quiz. Yep, I did that already.
I'm like, oh, we're doing our homework. I knew we were doing group meeting. I just was going down one, and so, yeah, I'm here. Okay, so now you guys are at what? Number 3?
We're at number 6.
Where'd you guys go? Come back to me. Okay,
so number 3, we want to make sure it follows all the rules, right?
Mm-hmm.
So the rules are, it has to be between 0 and 1. They have to all add up to 1. And they can't be a negative. So if you add all those numbers up,
they equal 1. And they're all less than 1, so it works out.
Yep. You got it?
No, I think I'm on the wrong. You guys, I promise I'll be better next time. You guys are on week 2 group meeting, right?
Week 2, lesson 4 group meeting.
I don't even have that question on here.
So then you have to go to the quiz.
The quiz.
And then you hit start.
The quiz?
In the group meeting, there's a start at the bottom.
Yeah, it probably doesn't even say quiz. It just says start.
Yeah, I'm in there. I'm in the group meeting.
For lesson 4.
Lesson 4 group meeting under week 2. And the question 3 for me is about blood types.
Yes.
Yeah.
Okay, so it says the blood types and proportions given in the table above define a probability distribution. Right?
And we said true because it meets all the rules.
Okay, the equals to 1 and all that, right?
Yeah.
Okay, got it.
Right.
And number 4, what is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places. And so would it be 0.45? Is that what that is?
Yeah. That's what we said.
My husband has type O. Okay, what is the probability that a randomly selected person will not have type O blood? So would it be 0.55?
Yes.
Yep.
Okay.
Okay.
Number 6. I'm with you guys. Now.
Okay. All right. Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person who identified as bladder cancer. Answer the following questions. That is not a fun job.
Oh. But what a way to give dogs a gift, you know? That's awesome.
Seriously, yeah.
I wouldn't want a dog to sit by me for that.
No, I don't want that dog near me unless I have a problem. Then the dog can come and check me out.
Yeah, exactly.
But I hope the dog doesn't find a problem. That's the thing.
Yeah.
Okay.
No, thank you.
So there's 7 bowls. So there's 7 options.
7. So 7 divided into 1, correct?
Yeah, so 1/7
Would be 0.143. Are we going? Oh, 2 decimal points. Okay. 0.14?
Is that what it said to 2? Oh, it says to round answer to 3 decimal places. So
Oh, 3.
0.423.
Oh, 143.
143. Whatever. I don't know.
Okay.
That's what I have. That's just not what I said.
0.14.
So we just want, okay.
0.143.
And it's only 1 dish, right?
1
out of 7.
So
Yeah.
the answer would be 0.143. Yeah.
What is the probability? Yeah, there's 1 out of 7, so 1 out of 7 chance.
Mm-hmm.
Okay.
0.43. That's a 7th chance.
So, okay, so then you guys ready for number 7?
Yep.
Yes.
Okay, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It's very unlikely that the dog would do this well by random chance alone, which the following statements is most appropriate.
I would say this
the dog
this
can do it.
provides strong evidence that they can.
Yeah.
Okay.
I know, but still not as good of, I mean, this is off subject here, but 22 out of 54, that's still less than half, but more than 0.143.
But it's significantly more than the 0.143.
Because that would be 14.3%, right?
Mm-hmm.
So you would expect them to pick it 14.3% of the time, but
Yeah.
they picked it 22% of the time.
They were
Or
random.
not, almost half.
Yeah, it's 40.7% of the time. So it's over 40, little over 40% of the time they correctly guess. So I think that it's like 4 times almost.
Yeah. Okay, so I say this provides strong evidence that dogs can detect bladder cancer.
Yeah, I agree.
That's what I put too.
Okay.
Do they have to tell us what M&Ms were? M&Ms are small chocolate candies, in case you were not aware. In case you live under a rock. Right?
With the candy shell.
Yes.
And it goes in your mouth, in your hand.
Okay, so the probability of drawing a red, we need to figure out what green is first in order to figure out what red is. So let's add them all up.
Oh, I almost missed that.
Well,
I
guess we don't really. Well, yeah, we need to. Well, it says the probability that's already there, so that one is 0.13. But there is nothing listed for green, so we're probably going to need to know that.
Oh, I see.
Yeah, number 9 is we need to know that.
Numbers and then minus it by 1.
What's that?
So for the green, okay, so number 8, red candy, that would be 0.13, right?
Yes.
Yeah.
And so then are you guys adding 0.13, 0.14, 0.13, 0.24, 0.20?
Yes.
That equals.
It's 0.16 is what I got for green.
Yeah, so you add them all up and then subtract that from 1.
Okay. Yeah, 0.16.
Okay.
That's
Okay.
I thought you said 1.4. You guys got 1.6 or
I got 0.16.
0.6 for green.
0.16 for green. Okay.
Mm-hmm.
Yeah.
So if it's not green, then it would be
0.84.
0.84.
Yep.
Is what's left. Okay.
Okay, so the ACT scores of students admitted to a medium-sized public university in the western United States were taken from CAPEX.com. The following summary statistics were calculated. Use information from the public university to answer the following questions. So half of the observations are less than or equal to what number?
Hey, my client just texted, said he's still waiting. He's not going to be on time. So we have more time.
Okay. Okay. So it would be 24.
Because you look at the median, if you lined up all the numbers, and the median is the smack down middle number, right?
Mm-hmm.
Sorry, yeah, median is the middle number.
Is the average.
Yeah.
So I would say 24.
That's what I
I'd say
was.
24, yeah, because that's the mean, or the median. Isn't it the
Okay.
median that you'd use for that?
I think so, because mean is the average, and median is
Yeah, the median is the exact middle number.
Yeah.
So I would do 24.
Yeah. Okay. The top 25% of students scored above what number? So that would be that's a tricky way of wording it, because it's actually the Q3, isn't it? Because it's the top 25%,
Oh, yeah.
which would be the 75th percentile.
Which would, would be 27.
Is that right? Do you guys agree?
Yes.
Okay. Okay. Ooh, rules of probability.
What would it be? So 27 or 28? Like 27 is where it starts. So it'd be 27.
They scored above what number? They scored above 27, because 27 is the 75th percentile.
Okay.
Okay.
Our last question? Holy cow. That was a lot easier, a lot less painful than I thought. Maybe I'm talking too soon, but.
Yeah. Some of these are, it's once you understand what the words mean and what the numbers mean, you're like, all of a sudden they're simple.
Yeah.
But until you figure them out, I'm like, the what now? The how now? What now?
What are you talking about?
I'm worried about lesson 5 because I'm like totally.
Well, when we finish this broadcast, we can talk about it for a little bit until my client gets here and
Okay.
kind of prep, and then you guys can go play with it till we get together later. Oh, where did my stuff go?
Uh-oh.
I clicked on something and my screen went away. There it is. Okay. Which of the following statements is not one of the rules of the three rules of probability? That's a rule. Probability that an outcome will not occur is 1 minus the probability that it will occur. That is a rule. The probability is high, then that one. It's that one.
Yeah.
Yeah, you guys agree?
Yeah.
Yeah, because it can't be negative.
Yeah.
Okay.
All right. So we
All
good
right.
to go?
Submit.
Submit.
Yeah.
Let's find out how we did.
Yay!
Yay! See,
Wow.
I need to have a third person, huh, Carolyn?
Yes, we needed you.
All right. Well, yeah, that's
Let's go ahead and stop the broadcast. We can keep talking, but we're going to go ahead and post it, okay?
Okay.
So it'll kind of do its thing. Hold on.